Hello friends, welcome you all. So in this video, we are going to discuss one more important topic of theory of computation, which is post machine. Now, post machine is something like Turing machine, but it has some benefit over Turing machine. So in this lecture, we will discuss the complete topic as post machine. So the post machine was first proposed by Emil Post. Emil Post. So after his name, this was considered as post machine, and it was given by Emil Post in around 1940s. 1940s. Now, this post machine, you can also call this post machine as post correspondence machine, or you can also call it post canonical system, or you can also call it string rewriting system. So basically, post machine, these are the other names of post machine. So basically, post machine runs on the concept of string rewriting, and that's why one name of this post machine is string rewriting system. So it rewrites the strings based on some production rules. So these all these things we will discuss about post machine. So I will describe the formal definition of post machine. So now post machine has four components. So four components are: first is alphabets. You can simply represent it as sigma. Then first component, it is first component. Then second is production rules. Here also you will have a production rules. So you can represent them as P. This will be a set. This will be a set. Then third is initial string. This is one string and it is represented as S. So this is called initial string of post machine. Then fourth is stopping condition. Now this stopping condition is nothing but a production rule, single production rule. So this is set of production rules. This is set of alphabets. So this is initial string, which is the string of alphabets. And then stopping condition is again a single production where uh, machine will halt. Machine will halt. So I will tell you, don't worry, I will tell you the example of this machine and I will show you how all these four components are mentioned. So I hope these would be clear. The post machine is four component machine, or you can say four tuple machine. First tuple is a sigma. This is alphabet. Then second tuple is P. This is set of production rules. Then third tuple is initial string. This is not set. It is single string and it is represented as S. And the fourth condition, fourth tuple is stopping condition. Stopping condition. So these four components are there in post machine. Now for production rules, again we are having four different types of production rules. So now I will tell you these four types of production rules. So first is replacement rule. In this particular rule, you will have, suppose you are replacing some very alphabet U with V. If the left hand side of any production rule matches within the string, then it is replaced with the right hand side of that particular production. Now U and V, this is replacement rule. So if U is occurring within the string, then it will be replaced by V. Then second type of production rule is removal. Now in this kind of production, you will have U, it gives epsilon. U gives epsilon. This is something like epsilon production. This is something like epsilon production that we have discussed so many times. Now, third rule is insertion rule. And in this particular rule, epsilon may be there in the left hand side. So this is the very important difference between Turing machine and Post machine. Turing machine and Post machine. In all mathematical models that we have discussed till now, and all mathematical models that are used by all mathematical grammars classified in Chomsky classification, epsilon cannot be in the left hand side. Left hand side left hand side of any production rule cannot be epsilon. But in case of post machine, if you are using insertion rule, then you can have epsilon in the left hand side of any production. And this rule can be applied anywhere within the string because epsilon exists between every pair of alphabets. So this rule can be applied anywhere in the. So here you will have epsilon in the left hand side and some variable v in the right hand side, or some string, or you can say you can this alphabet in the right hand side. So this is insertion rule. Then the fourth rule is halt rule. So this is nothing but the fourth tuple of your post machine. Fourth tuple of post machine. So this is halt rule. And halt rule will be like this. Like suppose you are having some alphabet U and it will give us halt. So if in at particular moment you find U within the string, then you can replace it with halt and then machine will halt. So it will stop processing. So these are the four tuples of post machine, and then these are the four types of production rules in the post machine. And now I will take some example of post machine, how it works, and then we will also discuss the differences, important differences between Turing machine and post machine. So friends, this is one example of post machine. So these are the tuples, sorry, these are the production rules which are represented as a P, set P, and this is the initial string S AAB. Now, if you identify the alphabets here, so capital A, capital B, these will be alphabets, and stopping condition of fourth tuple would be B gives halt. So, how it works, that I will tell you once. Now, this is P, this is S. So, I am writing here two more tuples of post machine as A comma B, and fourth halt condition is B gives halt. Now I will show you how it works. So this is very simple, and as I told you, we first see the occurrence of left hand side in a particular production in the current string, and then we can replace this with right hand side of that production. So here we have AB, first production as AB gives BA, and second production is AA gives B, and then third production is B gives halt. So now this is our initial state. Now we will start working with this string. So here we have AAB. Now this particular string is having the left hand side of second production at first position. So I can replace this AA with right hand side of this production. So it will become BB. It will become BB. So these two B's are there. Now Now, as you can see, this is our current string, and it is not matching with this left hand side of this production, not matching with this type of this uh, left hand side of this production. Now, first symbol is matching with the left hand side of this production. So I can replace this with halt. Actually, I'm not replacing it, but at this point, the machine will halt. At this point, the machine will halt, and this V, this B, the second occurrence of B will be unprocessed, will be unprocessed, and here the machine will halt. Here the machine will halt. So this is one very simple example of how this particular machine post machine works. We whatever in we start with the first production, and we matches left hand side of every production with the current string, and whichever left hand side appearing in the string first, then we replace, we use that production, and we uh, rewrite the string in this way. So this is how it works. So now friends, we will compare Turing machine and post machine on the basis of these criteria. So first is model. So Turing machine is tape model, or you can say tape based model, and post machine is string rewriting model. So Turing machine is based on the tape model, while post machine is based on the string rewriting model. Now operation here in Turing machine, as you know, on tape we perform all these operations: read, write, and move. So these three operations are performed on the tape. Now here, obviously, rewrite a string. We rewrite strings. Then, if I compare both these two on the basis of memory, so Turing machine has infinite tape for storage, while post machine has only strings, and it has strings means the only memory which is required to accommodate the particular string that is available in the post machine. Now, power. If I talk about the power, then both Turing machine and post machine are having the same power. That means it can recognize or handle recursively enumerable languages. So, post machine can also handle recursively enumerable languages. So if I talk about the power of these two machines, so it is same for both, same for both. Now if I compare these two in on the basis of complexity, then Turing machine is more complex as it is mathematical model. Post machine is less complex as it handles strings. So this is the comparison between Turing machine and post machine, and this is all about the post machine. So I hope this would be very much clear, and still if you have any question, you can always write to me in comments. I will definitely reply your comments. If you like any video of this playlist, you always please like and subscribe, because subscription are very important, and along with viewing, subscription are also very important. So please subscribe the channel. Thank you so much.